Alright, so today we're looking at radicals, and we're going to be using fractions and division of those radicals. So let's take a look at this one. We want to split this up into two separate fractions. So here's one, and here's your other one that we're looking at. Alright, so let's treat these individually. So this first one, 6 divided by 2 is 3, and then we have to simplify this. So I know my perfect squares. 4 is the one I'm going to look for. So I'm going to change this into 4 times 2, which will be, that's over 2, which will be 2 radical 2 over 2. So in this case, the 2's then cancel each other out, so I'm left with 3 and radical 2. So 3 plus radical 2 is my final answer in this case. Alright, let's take a look at another one. So we're going to do this, treat this the same way we did before. So I have 16 divided by 4, and then I'm going to go this way and do this one. So I'm going to write them as individual fractions. Alright, 16 divided by 4 is 4, and now I need to work with this. So my perfect squares, 48 is not a perfect square, but I know that I can pull out 16 and 3. So that's what I'm going to work with. 16 times 3 over 4, so that would be 4 radical 3 over 4. The 4's cancel out, and I'm left with 3. So the pieces I have are this and this. 4 minus the square root of 3. Alright, let's take a look at something that has a radical in the denominator. Alright, so the first thing I'm going to do is I'm going to get the radical out of the bottom, because we don't want to have a radical in the bottom. It's not acceptable for it to be down there in a final answer. So to do that, I need to multiply by this, and whatever I do to the bottom, I have to do to the top. So I'm going to do both the top and the bottom by the same thing. Alright, now I'm going to rewrite down here. So 8 times 3 is the square root of 24, and then 3 times 3 is the square root of 9, or that equals 3. So I could have just jumped to this and been okay with that down here. Now I'm going to break this up. So I'm looking for my perfect squares over here, and let's see, 4 times 6 will get me there. So I'm going to use that. So 4 times 6, and that breaks out to 2 square root of 6 over 3, and this would be a final answer. Alright, let's take a look at this one. So it's written a little bit different than this one was, but it still means the same thing. So it means that I have this and this. Now I'm going to treat them individually. So I don't want to do it quite like I did it last time. I want to simplify it first, because 32 is a large number to multiply with, and I would rather see if I could use something smaller. So I know that my perfect squares in here are 16 and 2, so that's what I'm going to use. And then I still have 6 on top. Let me get this out of our way. Alright, so I'm going to take all of this and bring it down here. I have a square root of 6. I have 16, and I have 2. The square root of 16 is 4, so now I'm left with square root of 6 on top. That's going to come out to be 4 and square root of 2. Now, all I have to get out of the denominator is the square root of 2. That's much easier for me to work with than 32. So again, whatever I do to the bottom, I have to do to the top. So now I have 6, square root of 6 times the square root of 2 equals square root of 12. And then 2 times 2 square roots would be 4, and the square root of 4 is 2. So I'm left with this on the bottom. All right, so now I'm going to rewrite. So this is what we have this is what we have thus far. And the 4 times 2 carried over from the other side is 8. All right, now this is simplified, this is not. I know that 12 breaks up into 4 and 3. And the square root of 4 is 2. So this is where we're at right now. Now, this can be reduced. 2/8 reduces down to 1/4. So you can write it like that, or you can write it like this. All right, so fractions and division with radicals. Give it a try.